All right, let's talk about machines. When we're talking about a machine, we're simply talking about something that transfers energy from one place to another or one form to another form. That's what we're talking about when we're talking about machines. And we're going to talk about simple machines. And usually simple machines are either going to multiply the force or they're going to change the direction. And technically sometimes instead of multiplying force we could actually increase speed out of that thing. So you cannot get more out of it than you put into it. There's no way to get more work out of a machine than what you put into it. That would violate the laws of physics. So work input equals work output. Remember, work is force times distance. So if we're talking about two things that are moving and the work that I put in, force times distance, I'm going to get that work out of it in terms of force times distance. So let's talk about it in terms of like a lever. So if we're talking about a lever, first of all, make sure you understand the word fulcrum. Fulcrum is the pivot point of the lever. And think about if you use a lever, so you've got some heavy object that you're trying to lift, and I use a lever, and I'm pushing down here to move this thing. I'm changing this energy. What I do usually with a lever is I can't maybe lift this object by itself. Maybe this is too much. Maybe that's 1,000 newtons and that's too much for me to lift. But by using this lever, I can apply less force, so a smaller force, but I'm actually going to move it a greater distance. So this would be it's going to be a heavier force. It's this weight of this object, but maybe it only moves a little bit. And so I don't actually multiply the work involved here, but I can multiply the force. So, maybe I can apply a force of 50 newtons to move a 1,000 newton object. But I have to give up distance in order to do that. So that force that I apply, I have to do over a longer period of time. So here's a better example, better drawing of mine. Notice that this distance is small over here. This distance is big. But I don't have to apply as big a force. But the two together multiply to give you the same thing. The work overall is done. But the lever allows me I'm not strong enough to apply that force. So I'll move it over more distance. I'll move myself, over more distance to move the other object, smaller distance, but I can now move that heavier thing. So here she is applying less force, just a little bit of force to do it. Think about a teeter-totter. If you're the small person, you always, you sit farther away from the fulcrum. You can balance the heavy person down here because your force is multiplied. However, the amount of work done on both sides is still the same. In order to figure out how much we can multiply force, that's known as the mechanical advantage. And if let's say the example that they showed you says, hey, I only need to push a 10 Newton force to move this 80 Newton object. Well, what we're going to do is find out that the mechanical advantage is 80 newtons divided by 10. It's the work that we did, or the force, what do I say? The output force out, divided by the force I put in. And that gives me the mechanical advantage. I can also figure it out based on the distance. In this case, what's going to happen is if this is true, if those numbers are true, this distance would have to be 8 times longer than this distance. Okay? So notice that this is known as the effort. The effort distance divided by the resistance distance. And assuming we don't worry about friction or any of those things, these will be the same. This will be the same. 80 over 10 is going to be the same as 8 over 1 in this example. There are three kinds of levers: first class lever, second class lever, third class lever. Let's take a look at pictures while we talk about them. Here's an example of a first class lever. First class lever, the fulcrum is in the middle. The resistance, we're going to call that the resistance, and I'm going to call this my effort. They are on opposite sides of the fulcrum, and notice that they go in different directions. So here my effort is down and the object moves up. That is a first class lever. In a second class lever, the fulcrum is at the end. Notice here, it's at the end. So here's my fulcrum, right here at the very end. My resistance is in the middle. Here's R. And my effort is at the end, at the other end of from the fulcrum. And I'm going, notice that these are going in the same direction. So second class lever, resistance is in the middle. If you just remember, every single one of these switches what's in the middle. So in a first class lever, the fulcrum's in the middle. In the second class lever, the resistance is in the middle. So what do you think will be in the middle in the third class lever? In the third class lever, that's where my effort is. So here's my effort, here's my resistance, and here's my fulcrum. And you know, a lot of times when I talk about third class levers, people always think, why in the world, that doesn't make sense. Why would I have a third class lever? That doesn't seem very good. And yet that's what we are. You know, our arms are third class levers. If I rake the leaves, I'm using a third class lever. If I use a shovel, those are examples of third class levers. I use a third class lever all the time. They're very, very common. We just don't think of them that way. But notice that the effort is in the middle here, okay? I have a pivot point at one end, and my resistance is on the other end. All right, so let's take a look at this person's arm. You know, here's your muscle here, your bicep. The bicep actually attaches to that bone. And then that's trying to pull this way. Here's my weight. You know, it's in my hand. That's at the other end. That's this R at this end. So I'm trying to pull up. This is going up. But here's my fulcrum. The elbow is my fulcrum. My effort in the middle. My resistance at the end. That's a third class lever. Be aware of those. Make sure you can you can figure out which class lever we're talking about. I think that's important. First, second, third class. It has all to do, like I said, with where they are. First class lever, fulcrum in the middle. Second class lever, resistance in the middle. Third class lever, effort in the middle. And we talked about directions. First class, they're going opposite. In the second and third class, they're going in the same direction. Those are important things for you to keep in mind. A pulley is really a lever. And depending on how you set it up, it could be a first class lever, it could be a second class lever. But the main thing that you do, or one of the main things that you do in a pulley, is change direction. So if you think about a very simple pulley, just one pulley system, you know, you've got a weight tied to a rope, it goes over the pulley and comes down and you pull. Really what you're doing is changing the direction. You're pulling down and the object's moving up. You're really not multiplying any force in that first basic pulley system that they show here. You know, the output is here, input's here. You know, so in other words, this is my resistance that's going up. Here's my effort that's pulling down. And notice that, you know, if we're talking about distances, because the pulley is round, those two distances are going to be the same. So the mechanical advantage of that is simply going to be 1. You know, you're not going to get anything more than that. And actually you're going to lose a little bit due to friction. So you actually lose a bit, but you get to pull down. And sometimes that's good because you get to use your weight to pull down. You can hook up a pulley a little bit differently though. And if you hook it up this way, that's, you know, it's a little bit different. I'm pulling up. Notice that, remember we talked about this a couple chapters back, and we talked about supporting strings, and we actually measured some of these things. And now, notice that I have a force up here and a force up there, and let's just say that this is 100 newtons. Well, those are going to now be split between these two supporting strings. So I don't now, at this point, I don't have to pull up with as much force. Okay? So I get to actually split the force between the two ropes. So this is actually a second class lever. notice that here's my resistance is in the middle. My fulcrum is actually the end. And the input is here, or the effort. You know, I just like, these are terms that we usually use when we talk about simple machines. It goes up. This would have a mechanical advantage of 2. In other words, if I put in 50 newtons of force, I can lift 100 newtons. That's what I mean by a mechanical advantage of 2. I'm not getting any more work out of it. I'm giving, because I'll have to pull up twice as much rope in order to get it to move. So if I have a combination here, if I have a, often this is called like a block and tackle, but if I have a combination of pulleys, I can now do both things. I can change direction, I can multiply forces. They show 2, but you could have pulley systems that have 10, 20, 30 pulleys in there if you really wanted to. And notice now, let's think about this. Okay, this one he's pulling down or she's pulling down on there. These 2 are pulling up. So we're splitting the weight between these 2. These are what are known as supporting strings. And then this one, the other third one, is just changing the direction. So there, I'm changing the direction. I'm getting more support. So the number of supporting strings is also equal to the mechanical advantage. So in this case, that mechanical advantage is going to be 2. Okay. So this one, notice that this one with 2 pulleys has the same mechanical advantage as this one with 1 pulley. But the advantage is I don't have to be up above the pulley to get this to move. So a lot of times with pulleys, it's just about ease for how you want to do it, what you're trying to do. Okay, we've talked about all this. Kind of went through all that as we were going through those. So I don't think we need to go through that again. So here's another example. This is, it looks like there's several systems. Notice how many ropes we got in here. We've got 1, 2, 3, 4, 5, and then we got this one coming down. So really there are 5 ropes that are all supporting this weight. And then this one is going the other way. So all of these 5 ropes are actually pulling up. Somewhere in here. And because of that, those are called supporting strings. So the mechanical advantage of this pulley is a 5. So therefore, she only needs to apply a force of 100 newtons to this 500 Newton object to get it to lift. If you think of a block and tackle system, you know, you can lift a car engine out of a car very easily, but you pull a lot of ropes. She's actually going to pull 5 times. If she pulls 5 feet of rope, this is only going to go up 1 foot. So when you gain mechanical advantage, you give up distance. You now no longer have to, or you have to pull farther.